NASA's new vision for space exploration returns astronauts to the moon, setting the stage to travel further, exploring Mars and beyond. To succeed in these new journeys, we'll need new tools, new technologies, and new methods for exploring. But all of these elements will need to be tested before we travel to those far-off places. This is the job of Desert Rats, Research and Technology Studies, to create a dress rehearsal on Earth for the space missions of tomorrow. It's dawn in the desert, and the RATS team is already hard at work on another field test. Similar tests took place during the Apollo lunar program. The experience proved invaluable in figuring out the capabilities and limits of equipment prior to them being used on the moon. NASA's new space program is called Constellation. For this new era in human exploration, missions to the moon will be longer and more complex than Apollo. To prepare, the RATS team is testing a new generation of equipment, taking it out of the comfort of the laboratory and into the rugged and punishing environment of the field.
Testing in what I would say is a representative analog setting and kind of a desert setting, for example, in a remote location, pretty much gives us a representative terrain situation that we would probably encounter on the moon and Mars without actually going to the moon and Mars.
The field is dirty, the field is hot, the field is cold, it's rough, it's bouncy, it's sandy, it's dusty, it's all the things that you don't have in the laboratory. So you can build a piece of equipment that works just great in a nice air-conditioned, carpeted laboratory. You get in the field and it breaks. And in some ways, braking is what we wanted to do because we'd rather have it break here than in space.
So what exactly does Desert Rats bring to a field test? Everything we want to use in real exploration.
Well, there's three main elements of RATS. There's spacesuits, robots, and tools. And we test them all together here on Earth in order to save time when we do go to the lunar surface.
Like a miniature spaceship built for one, the spacesuits used today by astronauts are built for zero gravity, perfect for tasks outside the space station in Earth orbit. But the RATS team knows the astronauts face a different set of circumstances on the moon and Mars. The suited astronauts will encounter some gravity, and they will need to do the work of a geologist, traversing on foot across dirt, rocks, and inclines.
On the surface of the moon, they'll have to walk around, they'll have to bend over and pick up rocks, they'll have to sit on rovers, and they'll need a lot more mobility than they need currently. So there's a lot of new requirements that we have to add to the new spacesuits.
The lessons learned by the Desert Rats field tests help drive engineers toward a better suit design.
What I know about doing lunar surface EVAs, I've learned from going to RATS. So I've learned a lot about how the suit moves, what it's capable of, what I shouldn't expect it to do, and then all the different interfaces I'm going to have to make sure that it interacts with while it's doing its job.
We have more cooling at Sydney as well.
In addition to knowing what to wear, Desert Rats is helping us decide what tools to bring for planetary exploration.
Some things are still pretty much the same. I mean, a hammer is a hammer is a hammer. And the only thing that changes is how well you can wield it and how heavy it is when you hit the rock in front of you. But we have expanded to more tools. We've looked a little bit at some of the more advanced analytical capabilities you might have in the field. But one of the other things we've really done is how do you get to where you're going? You know, using rovers, do you walk everywhere? If you walk everywhere, is there an easy way to carry stuff?
The RATS team also tests habitats, airlocks, science trailers for analyzing samples, communication links for voice and data, and other necessary exploration gear. But alongside the human explorers will be some other devices that can crawl, see, and move on their own. Some might think that when it comes to exploration, robots are sent first, and then humans later, working separately. The Desert Rats team is discovering the two actually work better together. No longer the stuff of science fiction, the latest generation of robots is being tested in the field to see how they can best serve as assistants in the exploration effort.
The benefit of having humans and robots work together is to maximize their efficiency. There are some things humans can perform more quickly than a robot could, and there's other things that a robot could do more efficiently than a human can. Some of the more mundane tasks that are very repetitive.
The use of robots is just one of the many mission activities that Desert Rats has conceived and demonstrated. From analysis of samples using a mobile science lab, to nighttime exploration, to testing the recharging capability of the suits, Desert Rats is writing the book on new planetary exploration. Desert Rats is also reaching out to the future explorers, inspiring students through educational events, showing them how math and science help us reach for the stars.
We need to engage the public and get the younger generation interested in what we're doing and get them excited, because they're really the next generation of explorers that will go on to other planets.
Through Desert Rats, the engineers who design robots, spacesuits, and all the tools needed for exploration work together as a team, talking face to face, problem solving, and answering the tough questions about exploration. So when humans do return to the moon, the knowledge of how to explore will travel with them. Knowledge gathered here on Earth by the Desert Rats team.
You know, there's so much you can only do sitting behind a computer typing up some dream requirements, but then you have to put it into effect. You have to develop that piece of equipment or that scenario of activity and then perform it somewhere in a relativistic type environment that's typical of what you might find if you go back to the moon and on to Mars. So hopefully this data becomes very meaningful in the sense of shaking out the true requirements.